Hello everyone, welcome to another tutorial by 12cad.com. Today we are going to learn how to create your own library for parts, how to create your own device, and how to create your own symbol, and how to create your own package. So I will use a resistor as an example, and I will use a datasheet I obtained from Panasonic's resistor library. And that data sheet will have all the dimensions and more to create the resistor package. However, this tutorial can apply to any part you want to create. You can create an integrated circuit part, anything. The general principles will apply. But for simplicity, I will use a resistor. Now, before we begin, we need to create our own library. In a previous tutorial, you remember that I added SparkFun Eagle libraries. Well, now I want to create my own library. To do so, I go to File, New, Library, and you see the new window appears, and this is the library window. Now, before we begin, I like to do a save as, and I will be able to choose the name of my library, and we'll call it library 12cad. And I like to save that there. Okay, so this window looks similar to the schematic window, but it's different. So we have in the top toolbar, of course, our open file, save file, print, but right next to it we have three very important options. We have edit a device, we have edit a package right here, and we have edit a symbol. Now, a device is something, for example, when you open up your schematic and you search for a part in the library, that is a device. Each device has attached to it a symbol. The symbol is what you see in the schematic. For example, the resistor would be the zigzag lines, that's the symbol. Then you have a package attached to it, and that is the physical representation of that resistor on your PCB board. So that's like the 0603 is the name of the resistor and has a physical representation. 0402, 0805, these are all the sizes of the resistors. So in order to create your own part, you need to create a symbol, you need to create a package, and then you need to create a device. So we will start by creating our own symbol. So if I want to create my own symbol, I will click on the symbol icon at the top, and you see a window appear. And since this is a new library, I have no symbols at the moment, which is fine. So I will create my own. I will call it resistor 0603 from 12cad. And I press OK. And it'll prompt me if I want to create a new symbol. Yes, I do. Yes. Okay. Now, before I get into it, your symbol does not need to look like a resistor. It is just a way, something to add into the schematic so it makes sense to you. Since creating a zigzag line takes a long time, whenever I create a part, since I know what it is, I just like to create a square box. It just makes sense to me. So I will create a square resistor, and it will have two pins, which the two ends of the leads of the resistors, and we will start from there. So before we get into that, I want to show you the schematic, not the schematic, sorry, the data sheet of the resistor so we can see what the size of the resistor will be. So this is the data sheet I obtained, and we will create. So since I want to create a resistor, in the schematic window, in the schematic for the symbol, it doesn't matter the size of the symbol. You can create it for any size you want because it's just a visual representation. So we will just create a box. And to create a box, you can go into the left toolbar here. It says draw lines, as you can see. It says draw wire, draw lines. So I will click that, and now I will create a box, and my box can be however I want it. So I start at the middle cursor, and I will go like so. There we go. So there's my resistor. And so now, since I've created the representation of it, what's more important than just that is to create the pins, right? We have two leads to our resistor. If you were to do a integrated circuit, you could have up to 128 leads, 128 pins, or even more. So this process can be replicated and scaled up to any um, symbol. So if we go to the left toolbar, we can see here that the bottom left corner we have draw a pin option. It's a red dot, red line with a gray square, draw a pin. So if I click this, you'll see up here is a green circle with a red straight line. Now that green circle represents a lead, a pin. So we can place this into our box like so. And you can see some options have appeared. Now that's one side of my resistor. Now I need the other side, of course. So in order to, see, I need to rotate this, and in order to do that, you can see the new toolbar that has opened up here. You have some options. The orientation of this can be changed. So I will rotate by 180 degrees, and you can see it has rotated, and I will click and add it to the other side. So, and once you're done, you can remove that. And you can see, so we have created the two pins, two leads, and we've created the square for the resistor. Now, what we need to do is assign these pins. We need to name these pins to something that makes sense, and we need to assign these pins to what they are meant to do. Now, in order to do that, you can see here, it says IO0, IO0. So I need to edit that, and in order to edit that, I will right-click on the pin itself. You can see if I right-click on the pin, it gets highlighted, and I can go down to Properties. So I right-click on the pin itself, I go to Properties, and a new window will open where I have a multitude of options. So first I want to change the name. I'm going to change the name to in1, because that's an input. And what I will do next is I will change the direction. Now I will explain this in more detail just after I do this change. You can see you have multiple directions here. You have input, you have an output, you have an input-output, and these three are important, and you have passive. Now passive is what we are going to choose because a resistor doesn't have a direction of flow. It can go both directions, so it's just a passive flow. So we will choose PAS, and we will change the swap level to 1. Now I will explain the direction in a little bit, but before I do so, I want to explain the swap level. Now swap level set at 0 means that the pins cannot be swapped. You must attach specific inputs and outputs to those pins. But for a resistor, since the direction doesn't matter which pin I attach what, it works the same way. I can set the swap level to 1. That means this pin can be swapped with another pin. And that, in this case, that means that the left side pin can be swapped with the right side pin. So, and it will still operate in the schematic appropriately. So I can do that and press OK and save. Sorry, I can press apply and it will change it, and then I press OK. I will do the same for the right hand side pin. Sorry. And I can right click on this and then go to Properties, and you can see it's called $2 now. I will change it to into, and also at the same time I will change this direction to passive and the swap level to 1. Now I want to explain what the direction means because it's very important. So if we go in the top toolbar, you can go to Help, Get Help. So I will go to Help, and I'm going to search direction. I'm going to search pin, and you can see here we have an option for pin. And if I make this a bit bigger, you can see that a pin has 6 possible options: direction, a function, length, orientation, visible, and swap level. So as you can see, there's a good explanation for direction. It's the logical direction of signal flow. It is essential for the electrical rule check. It is essential so the ego can determine if your schematic makes sense. So you have not connected pins, you have input pins, you have output pins, you have bidirectional input output pins, and you have some other options which, to be honest, I've used very rarely, but you could if you wanted to. And you have passive, and passive is for resistors, capacitors. So that explains that, and now we can go down even further and go to the swap level. And the swap level is an integer number. A swap level 0 indicates that a pin cannot be swapped. An allocation greater than 0 indicates that a pin may be swapped with any other pin in the same symbol. So there you go. So we can swap the pins in a resistor. For other circuits, like a integrated circuit, I recommend not attaching a swap level, because then you may mix up different connections which you don't want in an integrated circuit. For example, you don't want to mix up VCC, V input, and ground, because you will short circuit the integrated circuit. So now that we have done that, you can exit out of this. And actually, we are complete with our symbol. Our symbol is done. We can save this symbol right now by clicking File, Save. And we have successfully created a symbol for our resistor. Now, like I said before, the next step is to create a package. The package is the physical representation of a 0603 resistor on your PCB board. Now, to do so, you can go to this top toolbar here, and we will go to package, which is the middle one, and we will create, since we have no packages, we'll create our own package. We'll call it the resistor pack 0603 12 cat. You can name it whatever you'd like, and we'll click OK. And we want to create a new package. Yes. And now we have a window that looks very similar to the other one, but we have some more options. But before I get into this, since we are creating the physical representation of the resistor, I want to show you the data sheet, the measurements of a resistor. So as you can see here, I obtained this from Panasonic's website. It's for a thick film chip resistor. I recommend Panasonic for the resistor. They're very accurate and work very nicely and are easy to solder. So I have here the most important things you need to know. It's the dimensions in millimeters, you can see here, and the table showing the actual dimensions. So in this diagram, in this red top box, you can see we have the length, we have the width, and we have one more dimension, B, which represents how big the copper pad is, how big the copper pad needs to be so you're able to solder to it. So we need to replicate these in Eagle. And for an 0603, as you can see here, I have the length is 1.6 millimeters, the width is 0.8 millimeters, and the pad B is 0.3 millimeters. So we need to create a footprint of 1.6 millimeters, and inside that footprint we need two pads of 0.3 millimeters. So that means that the remaining space in between the pads is 1 millimeter. So now let's go back to our Eagle and we can start creating that. Now because everything is in millimeters, I like to change this grid. You can see this 1 by 1 grid here, I like to change it to millimeters because it makes sense to me. If you start at this middle, and if you keep an eye at the top left right here, this it says 0.05 inch and it has a relative position of inches here. Watch that as I go right. You can see 0.05, 1.1, 0.15, 0.2, and as I go up, you can see that changing as well. So the grid is a 0.05 by 0.05 inch grid. Now I want to change that to 1 millimeter by 1 millimeter grid because that, I'm sorry, we want to change that to a 0.1 millimeter to 0.1 millimeter grid. So we can go into view and then to grid, and you can see some options. So I want to display the grid. It's easier to see that. I want the style to be lines as it is right now. And here I can change the size. It used to be 0.05 inch by 0.05 inch. I want to change this to millimeters, and I want to change this to 0.1. At the same time, I will change this one as well. These two should match. And you can see now that we have a 0.1 millimeter by 0.1 millimeter grid. And if I press OK, I have created the grid. And if I zoom in, you can see now if you watch the top left right here, it's a 0.1, 0.1, 0.2, 0.3, 0.4, 0.5. So now we can actually begin creating our PCB layout for the resistor. Now, I like to create a trace. A trace is just a aesthetic visual representation of the resistor. It makes it easier to create add the pads, the copper pads later. So to create a trace, I like to go to the left toolbar and create draw lines. You can see here, draw lines or wire right there. And a new toolbar opened up at the top here, as you can see at the top. And the first thing is important is the layer. Now you have a lot of options here. Don't worry about the options. What I like to keep it at T place. It's the default one, and it's just for representation, informational purposes. So I keep it at T place. The other most important option here is the width. This width is too large. You can see if I click here, you see how large that is. I want to change this to 0.1 because our boxes are 0.1, so this should be a 0.1 as well. And now I can start at this cursor in the schematic window, you can see, and I can keep an eye at this top left corner and create a 1.6 millimeter line. So if I keep going, it's 0.7, 0.8, 0.9, 1.6 right here, and then I can click. Now I need to go up by 0.8, the width of the resistor. I have 0.1, 0.2, 0.3, 0.5, 0.6, 0.8. And then click, and then I can continue back and then finish the circle and click. And then when I'm done, I can press escape. And now I've created the physical layout of the resistor. But as you remember, we need to create copper pads that are of 0.3 millimeters of length and 0.8 millimeters of width. Now to do that, if you look in the left toolbar, you can see here it says draw a surface mount pad, or SMD. Now that is the copper pad that you see in your resistor. So if I click on this, I see a red box, and here I can actually change a few things in the toolbar up here. You can see the layer is 1, it's the top. Don't change that, that's fine. And the size here is very important. So as you remember, we created one that was in the data sheet, it was 0.3 by 0.8 millimeters. And I can press enter, and you can see that that has changed. Now I can actually place this right here. And so if I click, I have my copper pad. Now I need another one because we have two sides of the resistor, and I can place the other one right here. So now I have created the basics of my resistor. I have two pads. I have the resistor will sit on top here, and the copper will sit right here, and you can solder to this. But given that I have done a lot of PCBs, I see one issue here, that is it is extremely difficult to solder this since there is no extra copper on the left, and it's hard to get underneath the resistor once it's sitting there. So what I like to do is I like to increase the size. So if I right click on the pad and I go to properties, I have various properties here. What I like to do is actually double the length of that pad to 0.6 millimeters. So I have at least 0.3 millimeters to take my iron and solder to it. So I like to change that to 0.6. Also like to change the name to something that makes sense. I can call this P1, for example, anything you would like to call it. And I click apply, and you can see now this has increased its size, and I press OK. But it has moved slightly, so I will reposition this. Each box is 0.3 millimeters, and so we can see if we start here, it's 0.1, 0.2, 0.3, and we have an additional 0.3 millimeters of soldering space. I can do the same for I can do the same for the right hand side pad. If I right click, go to properties, I will change the name to P2, and I will change the SMD size to 0.6. Then I will reposition by clicking on move here and sliding it over 1. And now you can see we have 0.3 underneath the resistor and 0.3 additional. So we have created our resistor. That's all there is to it. So we have created a resistor. That's all there is to it. The trace pad. Now if you really wanted to, you could delete these white lines here, but I like to keep it because it's just gives me a sense that something will actually physically sit there, and I can't have another thing cross it, another resistor or something cross it. So it's just for simplicity. And so the pads are done, and we can continue to the next step, which we've created a symbol, we've created a package. Now we need to combine those two and create our device. Now our device is what says for the symbol to connect to the package. Since you remember that I labeled these pads as P1, P2, and the symbols as well, those pins. Now I need to tell Eagle that these two are connected in a way, and that's what the device will do. So I can save this by going to File, Save, and now I will go to the last option. The option here says Device. So I will click on Device, and since I don't have any other devices, I will create my own, and I'll call it the resistor 12-cat. You can call it whatever you would like. And so then I press OK, and yes, I would like to create a new device. And so now we have multiple windows here. On the left, in the black, is where your symbol will sit, your symbol. On the right, top right, is where your package will be shown. And on the middle right is where you will be able to assign pins to package, like assign what pin does what. And here is the various options here at the bottom right. You can do a new, add a new package. You can connect the pins, and I'll show you step by step how to do this. So before we begin, we need to add our symbol. So to add a symbol, if you look in the left toolbar, you have here add a symbol. You have the option to add a symbol. So I will click that. And now, since we only have one symbol, I can just select that and press OK. And I can put the symbol right there. And as you can see, it's very similar to what we created before. So now, I also created a package. So if I go to the right hand side window and I click on New down here, I'm going to add a new package. So I click on New, and as you can see, here is our package we created, and it's called resistor package 0603 12CAD. And I press OK. And as you can see on the top right, we have our package with a scale as well to make sure it's appropriate. So the final step is, as you can see in the top right middle column here, we have our package, but we have a warning sign right here, and that's because we haven't connected the symbol pins to the package pins. And so to do that, we will go down here and click on Connect. So if I click on Connect, so now you see pin, pad. A pad is the copper pad, and a pin is the schematic pin that we created. And if you remember, we called it in1 and P1. So I will connect in1 to P1, and I will select those. So you can also do P2, but for simplicity, I'll keep it 1 to 1. And I can click on Connect, as you can see. And now we say the connection has occurred. In1 goes to P1. Now I can do the same for in2 to P2 and go Connect. Now for resistors, this is really simple, but for example, for a integrated circuit like a microcontroller where you have several pins and the pad on the package has a corresponding pin in the symbol, so you have to take your time and match those so that when you actually have your PCB and you put the integrated circuit onto your PCB, the pins match up to the package, the actual physical integrated circuit. So that, keep in mind that otherwise if you swap them by mistake, you could have your VCC touching your ground or something like that. So just make sure you take your time here. For resistor, it's extremely simple. So once we are done, we can press OK. And now you see that it's a check mark. So that means we have connected all the pins to all the pads. And we are actually done. You've created a resistor successfully. So we can go into File, Save, and we are done with this window. Now I want to show you what this looks like in the schematic. So I will cancel out of this, since we are done here. I will go into our project 12cad.com tutorial, and I will create a new schematic just for testing purposes. And as you can see, we have our schematic window. I talked about this in a previous tutorial on how to do that. And so what I want to do now is add a part. And if you remember how to do that, it's in the left toolbar. You click on Add a Part. And so what I want to do now is create a new schematic and show you what our library, because as you can see in our library, we have our resistor. So I want to show you how to add that into a schematic. So I will go to File, New, Schematic. And then I will go to Add a Part, if you remember how in the previous tutorial I discussed this. So now I want to show you how to add your part, your device that you've created. Now to do that, we need to enable this library, because as you can see there is a gray dot. That means it's unusable at the moment because you are editing it. So we can right click and go Use and you can see now it's green. Now we can use this. So I want to create a new schematic. There we go. Now I'm going to add a part. It's in the left toolbar, add a part. I covered this in a previous tutorial. And now you can see it. Our library 12cat is an option. We can actually choose our resistor 12cat. And on the right, if you remember from the previous tutorial, we discussed how to add a part and the various definitions of this these panels here. We have our resistor symbol and we have our package. So we can go OK and add it. And as you can see, we have our resistor symbol in the schematic, and we can actually start adding electrical connections to it. You can see here that I can actually add connections. So that is the process of actually creating your own library, creating your own symbol, and your own package which is attached to a device which you can use in a schematic yourself. So this tutorial is complete. Please visit 12cat.com for the detailed step-by-step procedure with images if you need more help. Thank you. See you in the next tutorial.